Okay, so objects and classes. So we're going to learn about the difference between an object and a class. In general, a class is like a blueprint. We've seen classes so far and we've used them, but a class is like a blueprint. Let's say a blueprint for a house. How are you going to build a house? How many bedrooms, bathrooms, where they're going to be located, their sizes, square footage, that sort of thing. And so it's just a blueprint. That's what a class essentially is. Now, when you build a house based on that blueprint, you're constructing a house. Objects have the same relationship to a blueprint, to a class rather, as house has to a blueprint. An object is a construction, is constructed from the class based on its blueprint. Okay, so again, think of a class as being like a blueprint and an object being like a house built from that blueprint. Okay, so we're going to talk about classes and objects. UML, we'll look at UML tonight and look at how to find classes to create objects from them. We're going to get into different parts of how objects are constructed using something called a constructor. An object reference is really just a variable, which we've seen a little bit already with some of the other types of variables. We're going to look at how to use how one object can use another object and things like that. We'll look at some of the built-in Java library classes like date, random, and JFrame. We've looked at all these a little bit already, but now we're going to look at them even more. And we're going to distinguish between an instance and a static variables. So remember, in all the classes we used so far, almost everything said static. Now we're going to talk about instance. So static essentially means that it is a property of the class. Instance means that it's a property of the object, right? So static means once. It belongs to the class, and instance is of the object. So we'll talk about that a little bit. The analogy I like to give a little bit is that every house has its own bathroom, so that would be an instance of the house. But perhaps the community in general maybe only has one pool, so the pool would be static. We'll look at private data fields, get and set methods, and how they work. This property is one of the pillars of object-oriented programming, actually, called encapsulation. It's one of the primary reasons or primary benefits of object-oriented languages. And then we'll look at doing some more work in processing with objects. And this says objects and arrays, which we haven't covered yet, but that's about the only part of objects that touches on arrays. And what I'll do is I'll touch on that quickly, and then maybe we'll get a little bit into arrays, just enough so that you understand what we mean by an object in an array. So object-oriented programming involves programming using objects. An object is a person, place, or thing. So you could think of, the Human Genome Project is a blueprint of human beings, right? But every human being is a little different. But essentially, we all have the same genome, or we're based on the same genome. So the genome is like the class, and then each and every one of us is an object. So there may be only one blueprint for a human being, but there are 7 billion instances of the human object, human beings. Each human is an object based on the same blueprint. There's one blueprint, but there's 7 billion objects. So an object being a person, place, or thing, and we'll talk about that. So whereas a dog would have a different blueprint. All right, so, and anything's an object. An object is a person, place, or thing, so it can be a student, a desk, a circle, a button, whatever, can be considered an object. It has a unique identity, state, and behaviors. All right, so each one of you has a unique identity. You've got a name, a date of birth, probably a social security number, things that would uniquely identify you, at least the social security number would. And the state is what you're doing right now. So you're listening to a webinar. That's your current state. And later on, you'll be sleeping. That'll be your current state, right? So you have a state. And then behaviors, things you can do. Okay, right now your behavior is you're listening, I hope. Uh, and later on, maybe you'll be eating. That'll be your behavior. Okay, so and then you have all kinds of different properties, for example. And a property is something about you, like your hair color, your eye color, your height, your weight. Those are all properties that you have that you define about someone. So this pretty simple example right here talks about a circle. What is a circle? We'll look at this in a moment. I'm going to have to create a new package here. Any questions so far? None so far? Okay, here's our circle. That does not look like the right circle. Okay, class name circle, the data fields, methods. So this is going to be important because this is something similar to UML, although it's not quite UML. UML is coming up soon. So we look at the class name is circle, and you can create multiple objects of it. And one of the properties of a circle is the radius. That's a property. And the method is something it can do. So you can ask the circle for its radius. So again, classes are constructs that define objects of the same type. So again, think of a class as a blueprint, an object like a house, built from that blueprint. Java uses variables to define data fields or properties, okay, and methods to define behaviors, things you can do: walk, talk, listen, chew gum. So here's this simple circle class. If we were to look at how do you implement circle class, we'd see that this is how it's done. And of course, this is going to be not easy. Class circle. This is its constructor. And this is going to be useful because we'll see a couple of uses for it. What you like. It's not liking something here. I'm not sure what it is. That's what I can't like. Okay, we'll go through all this in a moment. But that's our current class. The radius is the data or the property. Constructors. And constructors are something that's called immediately to start something. And this is all going to come into play when you get into Lab 4. Because you're going to have a bicycle class that's going to look a little bit like this. And we'll go over this again. Double get area is going to return the radius. rather the area, which is simply the radius times pi. Here's an example of UML, and this is what you have to do for Lab 4 as well. You have to create you can do this in Microsoft Word, Visio, whatever you feel comfortable with. Paint. You can do it by hand and scan it if you want. I don't really care. But this is what it looks like. So an object is represented in UML as the class name, and then in this box area, and then a solid line, and then all of the data fields or properties listed with the name and the data type. Then all of the constructors occur first, and then all of the methods or actions happen after that. So this is a good one to watch because you're going to do something similar for bicycle. This just shows a couple of different objects being instantiated. Circle 1, Circle 2, Circle 3. And we'll see how that goes in an example. Okay, test simple circle. See if I have that one. If not, we can always... So the constructors are a special kind of method that invoke. So when you construct an object from a class, the first thing that happens is the constructor gets called. And we'll create a test class for this. So the way this would work is we'd have to create a I'm going to change something right here. The only thing I'm going to do right here is so that you can see what's happening. I'm going to call this the custom constructor. So let's talk about what each one is. Constructors. Typically, you have something called a default constructor, and the default constructor is a constructor that doesn't take any arguments. So no arguments. So the constructor, it's like a method, special type of method, takes no arguments. You also have something called a custom constructor, which is any constructor that takes an argument. Right? So the default one is always the one that takes no argument. And the custom one is always one that takes one or more arguments to it. And we'll see how both work. So a constructor with no parameters is referred to as the no-arg constructor. It's also generally referred to as the default constructor. I've always called it the default constructors. Constructors must have the same name as the class itself, but they do not have a return type. So, for example, if you look at these constructors, what's odd of the constructor compared to this method is that this method has a return type. Constructors never have a return type. They're not supposed to have it. So you always know what the constructor is in a class by two ways. One, the constructor will always have exactly the same name as the class. And two, there'll be no return type. Just the constructor name. Now you could call these public constructors. I don't think that's necessary. And this could be public as well. Though I don't believe that's necessary. It's optional. Constructors are invoked using the new operator when an object is created. Constructors play the role of initializing objects. So let's go to our test. The way you can create constructors, and I'll do two. That creates a constructor, a circle object called C1 on one line, calling the default constructor. That's doing, now we're going to do it on two lines. And this is actually how it tells you to create the bicycle. And then you can, so this creates the reference, the circle reference. And remember that because Lab 4 tells you to do that with bicycles. This is going to instantiate the object using the custom constructor. And I'll put in 10. Let's see, what's the default? Default is 1. So why don't we put in maybe 3? And it wants a float, or a double rather. That construction. Now we can simply do some outputting. Say system.out printf the area of the first circle is what does this want? Turns a double. %f, and look at this. We're going to say C1 dot. When you hit dot, all of a sudden you get all the methods, just like any other class in NetBeans. So I can simply click on it, because what I want is the get area. And then I do the same thing for the second one. The second, except now I have to say C2 for second circle. Okay, let's go ahead and run this. Okay, so you see the two messages I put in the constructors, the default constructor and the custom constructor. We go back to circle. I print those two system.outs in there so that you can see which one is getting called. And then the next thing, it says the area of the first circle is 3.14 so forth. Right? That's because it used the default value of 1 times 3.14 pi, basically. And the second time, though, it used 3, because I created it with a 3. So it's 3 times 3 times pi. And that gives you a different output. Right? Now, if I get rid of these system.outs, because normally you wouldn't want to have them in a constructor, and we run this again, now you just get those two values. Okay? So this test simple circle is essentially going to be like your Lab 4, and circle is going to be like the bicycle that you download, right? Any questions so far? So we saw these two examples. So we talked about the default constructor already. It's the constructor that doesn't take an argument. It's implicitly declared the class, generally called the default constructor. You get one automatically only if you don't provide any constructor at all. So if there's no constructor in here at all, Java will automatically give you a default one. However, as soon as you put a constructor, even if it's not a default one, Java will no longer give you a default constructor. So as soon as you create one constructor, you lose the automatic default one. So if you still want the automatic default one, then you got to put it in yourself. It's always best to put the constructor in yourself so you're not assuming one thing and Java is doing something else. Okay, any questions so far?